All right, so I'm taking a look at question number 7 on homework 5A. Oops. All right, so it says, Skippy throws a ball straight upward at an initial speed of 80 feet per second. From physics, it is known that after t seconds, an object reaching a height of h feet can be modeled by the function negative 16t squared plus v sub o times t plus h sub o. If Skippy releases the ball from a height of 4 feet, the height function is modeled by h of t equals negative 16t squared plus 80t plus 4. So there are 3 parts to this question. Part A says, as the ball travels upward, it reaches a height of 48 feet after t equals blank seconds. That's what I'm solving for. And so the way that I'm going to go about this is I want to first notice that here in this equation that is given, h of t is the height and t is time. And also we can think about what the shape of this would be and what this actually is. I'm going to draw a little picture over here. This is since it's negative and it's a quadratic, this is a downward facing parabola. And if I think about the situation, if Skippy releases the ball, the x-axis here will be time, and over here we'll have h of t, so the height based on the time. And so Skippy releases the ball from a height of 4 feet, meaning that at time 0, the height is 4 feet. And then it's going to go from 4 feet, it's going to go up, and then it's going to come back down. So this is a picture of what we're dealing with here. So part A says, as the ball travels upward, so we can look over here, the ball is going first up, it reaches a height of 48 feet. So height of 48 would be right about here. And we're just trying to solve for what t would be. So it tells us that the height is 48, and I'm going to solve for t. So if I go back to this equation that was given to me, I can just plug in 48 for h of t. This is part A. So I'm going to plug in 48 for h of t. So 48 equals negative 16t squared plus 80t plus 4. And I'm going to be solving for t. And so the first thing that I'm going to do is just set this equal to 0. So I'm going to move the 48 to the other side. And I'm going to get negative 16t squared plus 80t. And then negative 48 plus 4 is going to be a negative 44. And this is going to be equal to 0. So now that it's equal to 0, I could try and factor this. I could complete the square, or I could use the quadratic formula. This actually can't be factored, so except I can pull out a greatest common factor first. And so I'm going to pull out a GCF, and then we can take a look at it. And I don't think this can be factored, so I'm just going to end up using quadratic formula here. So I think all of these are divisible by, let's see, not 16, not 8. So these should all be divisible by 4. And my goal here would also be to take out a negative 4. So what's left is going to be 4t squared. If I'm taking out a negative 4 from 80, that's going to give me minus 20t, and then plus 11 equals 0. And so I'm just going to go ahead and plug this into the quadratic formula here. So I'm going to take opposite b, which is 20, plus or minus square root of b squared, which is going to be negative 20 squared, minus 4ac all over 2a. And I'm just going to work this down and simplify it as much as I can. 20 squared, this is 400, minus 4 times 4 times 11 is 176. 2 times 4 is 8. This equals 20 plus or minus the square root of 224 over 8, and then I want to try and reduce this by factoring. Um, 56, 2 and 28, 4 and 7. Okay, so it looks like I can take out a 4, and then I'll be left with 14 inside. So 20 plus or minus 4 square root of 14 all over 8, and then that can simplify because all of these are divisible by 4. So when I simplify that, 20 divided by 4 is 5, 4 divided by 4 is 1, 8 divided by 4 is 2. So my final answer here will be 5 plus or minus the square root of 14 over 2. And then I do just want to go ahead actually and put this in a decimal form because I'm trying to solve. And it says, I also want to pay attention, it says round all decimal answers to the thousandth place. So we want to pay attention when we do that. So I'm first going to do 5 plus the square root of 14 divided by 2. That gives me 4.371, and if I do 5 minus the square root of 14 divided by 2, that gives me 0.630. 629. Rounded a little bit too much there. Okay, so I get 2 answers. And so what this actually means is when I have a height of 48, which would be right about here, I do get 2 answers, because if you look over here, I have a point here and a point here. What I'm looking for, though, is as the ball travels upwards. So right here is where it's traveling upwards. So I'm looking for this first point when the ball is going upwards. What is t going to be? So it's going to be the lesser of the 2. So my answer to A is going to be the lesser of the 2, which is where I got the 0.629. So that's how I got that answer, 0.629, whoops, right here. And then part B, I can already go ahead and answer. It says as it descends, it reaches a height of 48 feet after. And so what it's asking is, when does this ball, so it reaches a maximum point and then it starts going down and it hits 48 feet again, which would be the second value I found, which is this 4.371. So that's why I plugged that in there. Okay, so part A and B are done. Part C says the ball hits the ground after t equals what seconds? And so we have to do a little bit of thinking here. And I'm going to go back to my drawing of the parabola. If the ball is hitting the ground, that would mean that I have a height of 0. So it's actually asking for this 0 right here. And so the height is going to be equal to 0. And so I'm going to go ahead and solve for that. So hopefully I can fit this all in. Moving on to part C. Okay. So this time, instead of letting the height equal 48, I'm going to let the height equal 0. So I'm going to do 0 equals negative 16t squared plus 80t plus 4. And I'm going to go ahead and solve this one. So first things first, I'm going to take out a negative 4, just like I did before, try and factor this down to make my numbers easier to work with. When I take out a negative 4, I'm left with 4t squared minus 20t. If I'm 4 divided by negative 4 will be minus 1 equals 0. All right. So I'm going to go ahead and use the quadratic equation because I don't believe this can be factored. When I solved this before, I don't think I could factor it. So I'm going to go ahead and plug this straight into the quadratic equation, quadratic formula. So opposite b will be 20 plus or minus the square root b squared minus 4 times a times c all over 2a. All right, so I'm going to go ahead and simplify this inside. 20 squared minus these two negatives will cancel each other out. So I'm going to have 20 squared is 400. So I'm going to have 400 plus 16, which is 416. All over 8. And I can, because I want this in a decimal, I'm just going to go ahead and solve it from here. So I'll do 20 plus the square root of 416 divided by 8. Do that first. Okay, so I got 5.049, which will round to 5.050. And then when I do 20 minus the square root of 416 divided by 8, keep messing that up, 20 minus the square root of 416 divided by 8, I get negative 0.0495, so that would be 0.50. So thinking back to our graph, if you notice, since the ball was thrown from an initial height of 4 feet, that is where we get this zero value, this negative value, sorry, over here, because the ball, because it was released from an initial height of 4 feet, this value actually didn't exist over here. So we can go ahead and get rid of that one. And so if I'm trying to figure out when it hits the ground or reaches 0 over here, it would be this value of 5.050. And so that's how I got my answer right here, 5.050. All right, that's it.